Um, Welcome back. We're going to do a second question now on mechanics, and it goes like this. It says, given that A is equal to I plus j, and B is equal to I plus 3j, find lambda. It says, given that these two things are true, it says find lambda if A plus lambda B, if A plus lambda B is parallel to minus I minus 3j. So is parallel to minus I minus 3j. Now sorry, I mixed two questions. So it says, sorry about that, is parallel to the vector I. Okay, so now we need to translate that into maths so that we can solve the problem. So we solved already a couple of these in class, but just in case they didn't make too much sense when we were there, I wanted to go over it another time. So here we have one vector, which is going to be 2i plus j, so that's going to look something like, I'm just going to draw it quickly, to 2i plus j, something like that. More that way than that way. This is our vector, this is our 2i, and this is our j. And then we have another one which looks like 1 and 3j, so that's like 1i and then 3 of these, so that's much more steep. Yeah, so this is our vector b, and this is our vector a. And this is 3j, and this is I. So what this is saying is, given that you've got these two vectors, find a number, lambda, which means that when you add a plus some number, that number that we're looking for, times b, we get something in the end which is going to be parallel to I. So in this direction. So it's not going to be vertical at all. So some combination of adding these, this plus some multiple of that, which should give us something which goes along this direction completely. So for example, yeah, so okay, so let's do it. So the way we approach these is we write a plus lambda b. So we write this here. We're going to write it down here in a different form. So a plus lambda b is really going to look like the components of a, which are going to be in the I and the j direction, plus lambda times the components of b, and that's going to have to be equal a vector which is parallel to I, which means that the component of I is some number, but it means that the j component is 0, right? There's none of this vector that's in that direction, so we can say here that j is equal to 0 if you have something parallel to the I. So therefore we know that that's going to be 0. And a plus lambda b, we know the components of a are 2i and 1j, so that's our 2i here and our 1j there. That comes from this 2 and that 1. And then we look at the components of b, because this is a plus lambda b. Components of b are 1 and 3j, so we've got 1 here and your 3 here. And basically we don't care what this is, because the component in the eye can be anything we want, because it doesn't matter how long it is in this direction. What's important is that it's parallel to the eye, so that there's no diagonal or up or anything like that. So this is not, that wouldn't be allowed, and neither would that be allowed, but all of these are allowed. So we don't care about how much goes in the eye, we really just care about the fact that this row here gives us 0. So these are really two equations, and it looks a bit weird if you're not used to seeing them very much like that before, but there's actually two equations here, and we're gonna just need the second one for our purposes in this video. So really we are interested in this one here. Okay, and the lambda, you could use it for 2 plus, you could use it for the top one also. There's another equation here which includes the lambda, so 2 plus lambda times 1 is equal to some number, but we're interested here in the second one. So if we write that out, it would look like 1 plus lambda times 3. We normally write the number first, and then that's equal to 0. So if we subtract 1 from both sides, we are going to end up with just the 3 lambda here. The 1 disappears and it appears on the other side. 0 minus 1 is minus 1. And then if we want to know what lambda is, we divide both sides by 3. And we end up with this much. So that would be our answer for lambda, in the sense that what they're telling us here is minus 1/3. It means that if you get this vector here, the b vector, and you multiply it by 1/3, which means you make it a third of its size, so it's going to be a smaller guy, like that. And you flip its direction, it's minus, right? It's minus 1/3, so we're going to flip the vector to be negative. Wow, I don't know what happened there. Sorry about that. And if we flip the direction so it points down, then so what it's saying is that if you add this thing here, plus a third of this guy, and you turn it upside down, then you get something. Let's do it here, something like that. Then you get something that is parallel to the eye, i.e. your final vector goes from your initial point to your final point, and that's just parallel in the eye, and that makes sense. From our picture, you go so much that direction, and you come back like that, and you end up with something that's the resultant that is in that direction. Right, so that's what we've done in this question. There's a bunch of other similar ones, and let's see if we have time to do one more. 7 minutes, we might be able to fit in a quick one. We've got about 3 minutes, so let's see. Okay, let's do the other one, parallel to the j. So in the next one it says find mu if mu a plus b is now parallel to j. Right, so if we do the equation again, now the mu is next to the a and not the b, so then we can write that mu times a plus b, and we can rewrite it as mu times a, which is, what was it, 2 on 1, 2 in the I and 1 in the j, plus rb, which is 1 and 3. That's got to equal something parallel to j. If it's parallel to the j, then the I is what is 0. It's parallel to j, this number will be something, but the I will be 0. So now we take this equation, the top, which is the one that we're interested in, and we say 2 mu plus 1 is equal to 0. Therefore, subtract 1 from both sides, we get 2 mu is equal to minus 1. And running out of space here, but mu, if we divide both sides by 2, 1 over 2. So mu is 1 over 2, and we've solved the second one. So you can see that can be really done quite quickly once you get the knack of it. Alright, so hopefully that's been useful, and I'm going to go on to the next question now. Alright, take care. Just in time.